Hello, everyone that's coming in. Happy Wednesday. Thank you so much for joining us. I'm just letting everyone in from the lobby now, so just bear with us for a couple of moments while we let everyone in, and then we'll get started. Hello, welcome everyone. All right, let's get going. Happy Wednesday. Thank you for joining us on this webinar about understanding heat pumps for strata. We're super excited to be here today, and we can't wait to share everything that we know about heat pumps in strata with you. So for those of you that don't know me, my name is Ailsa and I'm a Sustainability Engagement Coordinator at the City of Sydney Council. This webinar has been organised between myself, City of Sydney Council, also North Sydney and Waverley Council. We have Rachel, who is the Sustainability and Resilience Coordinator from Waverley Council at the top of your screen. And we also have Ian as well, who's the Sustainability Project Officer from North Sydney Council.
So welcome everyone. In the spirit of reconciliation, we would like to acknowledge the Camaragal, Gadigal, Bidyagal and Birrabirragal people who traditionally occupied the Sydney area and their connection to land, sea and community. We pay our respects to elders past and present and extend that respect to all Aboriginal and Torres Strait Islander people today.
All right, so an agenda for today. We know electrifying our apartment buildings but removing gas is a really important step to supporting our strata communities to reduce emissions, save money, and also strive towards net zero. However, as we know, replacing centralised gas, hot water, and pool heating systems can be challenging and complex. So today we've brought together some technical expertise to discuss barriers and solutions to heat pumps, and also to hear from champions in the strata space and to learn from their experiences and successes. So we have 5 speakers for you today. We have Conrad and David from Oricon. We also have James from Moore Park Gardens, David from Bay Gardens in Maroubra, Jackie Wrong from a building in North Sydney, and there will also be plenty of time for questions at the end. So I know some of you submitted some great questions during registration, but yeah, we'll also have plenty of time to go through those at the end as well. So just a bit of housekeeping. At the top of your screen, you should have a Q&A box. Please use this to answer questions or to ask questions. We'll be keeping an eye on that chat as well. We'll answer some in there as we go, and then we can go through them at the end. And all our fabulous speakers will be sticking around. So if you've got questions for each of them, we can get to them at the end as well.
So I would like to warmly welcome David Robinson and Conrad Perry from Oricon. So David is a senior mechanical engineer who has experience in designing and retrofitting all electric buildings. And Conrad, he is a hydraulic engineer and he's very passionate about efficient hot water system design. So welcome to you both.
Thanks, Rachel. So I'd like to start with a quick acknowledgement of country. So paying my respects to the traditional custodians of the lands on which we meet today. I pay my respects to elders past, present and emerging, and extend that respect to Aboriginal and Torres Strait Islander people joining us on the call today. Next slide, please. So just a heads up in advance that there's quite a lot of detail on these slides that we've got quite a short presentation time, so I probably won't cover everything that you see, but the slides will be available afterwards if you'd like to dive into the detail a little bit more. So the current situation we have is obviously the Paris Commitment and other government agreements mean that Australia is looking to decarbonise as countries around the world, which means that gas is being phased out for domestic new builds around Australia. So we've seen regulations in different areas, so like the ACT and Victoria, which have both made moves to remove gas from domestic builds, which is just great to see. So that's leading to electrification and sustainability pushes. So there are a range of ways to produce domestic hot water. So existing gas systems, point of use instantaneous units, electric storage with single or three-phase electrical connections, and heat pumps. But heat pumps are the most efficient and generally the best choice for large-scale applications, particularly in the Sydney area where the climate means that they can perform really efficiently. So within our presentation, we'll touch on some key design considerations and also touch on the importance of pipe insulation and the impact that can have. Next slide, please. So this slide covers the different range of heat pumps. So the way heat pumps work is quite different to a traditional gas boiler. What they do is that they transfer heat from one location to another. So there are three main types of heat pumps that are used in Australia. So there's air source heat pumps, which transfer heat from the surrounding ambient air and transfer that into hot water. There's ground source, which have a loop within the ground, which transfers heat from the ground into the water. And there's water source, which can transfer heat from a water source. So as noted on the screen, that means that you can extract heat from the mechanical system. So heat recovery, in essence, extracting it from the condenser water loop or from chilled water loops within the building. Next slide, please. So why heat pumps? So one of the starting points for the push for electrification is that you can achieve carbon neutral electricity. So unlike gas, you can produce electricity from renewable sources, so wind, solar, hydro, etc. That has zero emissions associated with it. Heat pumps support sustainability certifications. So we've noted WELL, Neighbours, etc. Green Star is another one because of their efficiencies. They offer good payback, so that there are higher upfront costs, but they're much more efficient than gas boiler systems and have a higher coefficient of performance. So what that means is that's the ratio of useful energy that you get out of 1 unit of electricity. So that means that you're getting much more useful energy out of it. So more bang for your buck in terms of energy terms, which and all of that translates to the ability to reduce CO2 emissions. So particularly if there's renewable offsets or solar power being generated on the building. So if there's green power or the like. At the moment, at peak times in Sydney, it's likely that heat pumps are producing similar or slightly lower emissions than a gas boiler system. But outside of peak periods, and particularly through summer periods where there's warmer ambient conditions and the heat pumps become more efficient, it's likely that the heat pumps have lower emissions. And the key thing to note is that's only going to improve as the grid continues to decarbonize. The advantage for heat pumps is only going to grow and grow. And you can see that in other areas. So Tasmania or New Zealand, which have a high proportion of hydroelectricity and so a much higher renewable share of the grid, they're already at the point where as an electric element produces lower emissions than a gas boiler system, and a heat pump system is an order of magnitude better than a gas boiler system. Next slide, please. So the payback period that can be achieved, so that's going to depend on the specific applications and the nature of the consumption associated with that building. So if there's more water being consumed, then it's likely that the payback period is going to be reduced because the operational efficiency advantages are being accelerated. Where there's lower water consumption, that payback is going to be that payback period is going to be extended. There are other factors, so the heat loss associated with the system. If the pipes are well insulated, that'll reduce the heat loss. The specific plant that's chosen and the coefficient of performance, so how efficient it is, And it's important to account for the seasonal coefficient of performance, so the SCOP number you see on the screen. So often what you see in the headline performance for a heat pump is the efficiency at a fixed point in time. But as I mentioned earlier, the efficiency of the heat pump depends on a range of factors. So it depends on the load, it depends on the water temperatures, and it, for air source heat pumps, it'll depend on the ambient conditions as well. So as the temperature gets warmer, there's more energy in the air, it becomes easier to transfer that heat, and the system will become more efficient. Next slide, please. Spatials. So one thing to bear in mind is that gas hot water plant is spatially quite efficient. So an equivalent heat pump system is going to use up more space. So you can see from the diagrams we have on the bottom of the screen, and we've got a person there for scale to so you can see the get a sense of the size of the plant. The heat pump solutions are going to take up more space, and for most efficient operations, they're going to require storage. Worth noting that storage can be placed in a separate location to the heat pumps, which allows for more efficient configuration of the building. Next slide, and I think I'm handing over to Conrad at this point. Thanks,
Yeah,
Conrad.
thank you, David. Yeah, so as David touched on spatials, you have to consider where you're going to put all the equipment. So typically a heat pump system may require 3 to 4 times more space than a gas system. So where are you going to put the tanks? Where are you going to put the heat pumps? How are you going to ventilate it as well? If you're using an air source system, you need to consider makeup air, because if you were to enclose it in one room, an enclosed room with no ventilation, you will essentially take all the energy out of the air until it's 1 or 2 degrees in that air. So capacity. So this is where it is important to effectively size a system based on actual usage. Previously, we've typically oversized systems 2 to 3 times more than what they have to be. So if you can effectively size a system, then you can effectively reduce the spatial requirements as well. Cost. So a heat pump system may be 2 to 3 times more cost than a gas system, but you've also got to consider where are you putting it, and is that space usable or is it allocated plant space? Type of refrigerant. So typically you'll pick a refrigerant that is suitable for your climate. So natural refrigerants like R290 or CO2 do perform really well down in winter temperatures. And it's important to consider sizing based off a worst case scenario. But typically when you do size off this, the efficiency will be even higher because of the seasonal coefficient performance. So if you size for a worst case scenario of say 10 degrees or 5-degree ambient, during the year you'll see a much higher performance than that. Noise and vibration is important. So because there's moving parts in the system, typically you've got the compressor. The compressor generates a lot of noise and it transfers a lot of energy into the plinth or concrete structure that it's sitting on. So how do you isolate that and acoustically and the noise as well due to the fans rotating? Electrical requirements. How much electrical capacity is required for the system, and do you need to increase, or have you taken into consideration startup capacity or the location of the plant? And then drainage. If it's a humid environment or any sort of environment, you'll see condensate drainage is required for heat pumps. And then finally, access and replacement. It's one thing to put all the equipment into a room or on a roof, especially during construction, but how are you going to remove it? So just for note, there's a door there that's 850 mil, which is the only access to a particular plant room. So you've got to consider what equipment can actually fit through there, if at all. Next slide, please. So, as David touched on, heat loss. Heat loss is really important. You don't really realize it. It's one of those things that is just happening in the background, but can account for more than 30% of the overall plant capacity usage. And in a residential tower, the hot water is reticulating 24/7. So that's the compliance requirement to 3500, and also ensures that if someone does turn on the tap, they're not going to have to wait for, you know, half an hour for the hot water to come out. So just as a case study, something for anyone interested to read later on. 3500, which is the plumbing code, has very poor insulation requirements. So just by increasing it, you're providing a passive solution that doesn't need to be looked at or touched after installation, and the saving of this is very significant. Next slide, please. So pipe sizing is also something that is underestimated, or overestimated, I should say. So the plumbing code, if you have a look at the screen here, there's some good research that Deakin Uni has done with funding by the HCAA. For reference, in red is the calculated capacity based off the plumbing standard, and in yellow is the actual. So typically the peak flow rate is, a quarter than what it has to be. What does that mean? It means that if you're sizing the hot water pipework, then it's using more energy than required, because the bigger the pipework, the more heat loss you get through it. So just by, again, increasing and improving the insulation, there's significant saving there. Next slide, please. I think the final thing, I guess, to consider is how water efficient are the fixtures. So something that may be overlooked is that may reduce the overall energy requirement. So showers are normally the biggest user of hot water in an apartment. So an incentive might be to look at reducing the water demand. So instead of a 9 litre per minute shower, you might have a 7.5 litre per minute shower. And just by changing that, you significantly reduce the energy usage in the hot water plant. So that is our presentation. Yeah, so thank you. Conscious of time here, we've probably gone a little bit over.
No, that's great. Thank you so much, Conrad and David. That was super interesting. I've seen a couple of questions come through, but we will come to those at the end, unless you want to jump into the Q&A box and answer them now. I'd now like to introduce James Delaney, who is the Senior Building Manager at Moore Park Gardens in Redfern, and he's going to be speaking to us about his experience upgrading to heat pumps for a swimming pool. So over to you, James.
Lovely. Thank you very much, Elsa. So start quick introduction. My name is James Delaney, the owner of Alliance Management Services and Senior Building Manager here at Moore Park Gardens in Redfern. Moore Park Gardens is home to over 1,000 residents across 4 strata plans and a community association with 575 apartments built between 98 and 2000. The complex includes a beautiful big pool. It measures 8.5 metres wide by 24.5 metres long, and originally built with a gas boiler system to heat it. So in late 2019, as the gas boiler systems were reaching the end of the serviceable lives, the Community Association engaged a heating specialist who conducted a bit of research and found that the heat source pumps are the best way forward to heat the pool. Following a review of that report, they proceeded in early 2020, and everything went pretty much smoothly. So moving on to the next slide. Thank you. So here I've got a bit of a cost analysis for you. So as you can see, the energy output costs before and after the heat source pumps were installed. I'll give you a second just to register those numbers. But ultimately, the conclusion is, as you can see, the cost of heating the pool has increased following the installation by approximately $2,800 per annum. Lovely, thank you. So moving on, upon installation, the Community Association were faced with a number of issues which sadly were not really anticipated. With number one, and predominantly the main issue was with the installation being directly underneath the pool, all of the piping and the concrete slab was subjected to the cold recirculating air, meaning that the refrigerant air required, the pumps had to work twice as hard because simultaneously it was being cooled at the same time. So that was one serious issue that they had to deal with. And in 2021, when I came on board, the pool temperatures were fluctuating quite sporadically. There was discussions about installing a ducted planning system to direct the air away from the systems. But ultimately, I contacted Evo Heat, who the manufacturers and installers. They were able to come up with a number of cost-effective solutions to maintain a steady temperature, including frequent use of pool covers when not in use, installation of pipework, sensors recalibration, and a more impactful scheduling of the operation that the pumps are running to. So over a 6-month period, building management, we closely monitored the effects that those had, and we did make weekly adjustments. But since then, with the odd exception to poor weather conditions, such as the weekend just gone with those bitterly cold winds, inclement weather, the pool has actually maintained a consistent temperature of approximately 26.5 degrees. There's also a number of factors that go into there, including swimmers, which is quite surprising, but the heat losses can be almost as much as 50%. So moving on to the next slide. So in regards to sustainability for the source pumps, I do firmly believe that with the correct application and installation, they're most certainly the way forward. There's no doubt about it. Unlike Moore Park Gardens, they weren't able to see a financial benefit to it. The system is installed on a common house board that utilizes power from the grid. If we had solar, it would be a different outcome, and there would be a substantial amount of saving. So I think regardless whether it's heated by gas or electricity, it's really all about the sustainability factor when it comes to an outdoor pool, in my opinion. But moving on to the next one. Thank you. So regardless whether like the pool's heated by gas and electricity, I was just saying, I can't stress enough how much the pool covers should be applied. I've seen far too often pools that haven't been covered, and with the costs to regain a temperature, you've got chlorine costs, evaporation, etc. They're all significant costs that they add up at the end of the day. And just to take a 2 to 5 minute sort of application of a pool cover, it's well worth the time. So while heating the pool covers do keep a substantial amount of heat within that pool, therefore saving you a substantial amount of money. So yeah, and if you do have an on-site building management team, make sure that they're being proactive in reviewing the times of use and making sure that if the pool isn't being used and certain times, especially later on of an evening or earlier in the morning, it wouldn't hurt to cover it. And as you saw in the earlier slide, we do close the pool an hour earlier of an evening during the winter hours, and we leave the pool covers on an hour extra of a morning. So that just helps us. The radiant heat has an impact on that as well. So as soon as that sun hits that pool, we find that the temperature sort of maintains at a level where the pumps don't have to work as hard as where it is in the shade. So that's pretty much a key aspect. So yeah, if going back to what the gentleman at Oricon just mentioned, there's a lot of factors to consider, not just whether we go for a heat source pump upgrade, but it's how that application happens and the factors that you've got to take into consideration going through that position. So yeah, that's pretty much it from myself. It's short and sweet, but I'm happy to answer any questions at the end of the webinar, or if anyone wants to discuss anything further, I'm sure the team at Sydney City Council are more than happy to pass on my contact details. Thank you.
Thank you so much, James, for all that lived experience. That was excellent. I would like to introduce David Walton, who is a committee member who project managed the installation of a solar and heat pump upgrade to his building. Thank you, David.
Thanks, Rachel, and hi, everyone. Yep. So a little bit about our project. You can see by the map there, we've got solar sitting on our roof. So back in 2020, I put a proposal to the committee to actually do two things. One was put solar on our roof, and also then to potentially replace our hot water system with heat pump from the gas. I got approval to put in solar first. I think that was more just budgetary, so we did that in 2020, and that was a really important step for us because that basically reduced our ongoing common power bill from around about $5,500–6,000 a year down to minus $1,500, I think, in the first year. So we saved about $7,500 in real terms. At the same time, we also put in tempering valves across the 50 units. The following year, I guess I'd got sort of pre-approval to pursue the heat pump approach for hot water on the basis as when our gas boilers next failed, we had 4 275-litre gas hot water heaters, each costing around about $8,000 to replace. So we agreed that the next time one of those failed, that would be the logical time to put in our heat pump system. So we did that. Total project cost was around about, for the heat pump, was around just over $50,000, and the solar was around about $30,000. And as you can see there with the annual savings, our total gas cost was around about $30,000, and common power around about $5,000 or $6,000. So you can see it there. Rachel and the Waverley Council team did get an independent person to validate all our numbers, so which was slightly better than mine, but basically a 2.3-year payback. Our annual electricity bill currently is around about $8,000 for everyone's hot water and common power. So as I said, it's a massive saving for us. Big part of that, well, both the heat pump has been sensational, but also the solar. If anyone's considering going into a project like this, if you can get solar on the roof, it really, really helps. So we sized the solar at 30 kilowatt, which is not far short of what the heat pump runs. So we just run it all day, every day. Well, I say run it all day, every day. It's on demand, the heat pump. We have 2,500 litres of hot water storage, which is also very important to consider. I think the Oricon guys mentioned it too, that heat pumps do take a lot longer than gas to recover. So you do want to have ample storage for your peak periods during your daily peak over the course of the day and the year. Thanks, Kaylee. I think next slide. So one of the challenges that we faced in putting this system was, how do we recover the cost? Given that most units have gas and the metering system is owned by Gemina, which is in each, hot water meters in each unit. So they weren't very keen on us providing the data for us to allocate charges or even indeed for electricity companies. So that was a real challenge for us. But I did an analysis of every single apartment, and pretty much everyone was paying more than, most people, just the standing fee alone ran, $60 to $100 a quarter for a single owner on a pension sort of thing, or on a rebated system. So the amounts that we put forward, to what we decided that we would add into our strata levies, an amount for the owners to pay for hot water. So worked out roughly $60 per bedroom per year is what we're charging, which basically covers our cost for the heat pump systems. Everyone seemed happy with that, and which is why obviously we got approval at the AGM to spend the money on this system. So it's worked brilliantly well for 3 years. We've just got a single Mitsubishi Q-Ton 30 kilowatt unit that works wonderfully well. In summer months, it obviously doesn't work quite as hard, and electricity bills at around about the $1,500 mark in the warmer months, warmer 6 months, and in the colder months around about $2,500. I do have a heat booster element in one of our storage tanks, just just for the real peak times, cold days, just to make sure that we're covered off there. So yeah, in essence, it's been a really positive project for us. A couple of other challenges we had. We were retrofitting a 4-boiler gas system, which is pretty much where we've got our storage. So yeah, I'd say we're probably doubling the space of storage, probably not quite so much 3 times of what we had with the gas system. As you can see there, the heat pump unit, the ketone unit, sits outside. It's actually under a balcony, but sits outside. So we're making use of ambient air. There's been no real issues with that. It runs very quiet, runs pretty much like a modern house air conditioner. So it's very, very quiet. Had a couple of challenges with the the cold air blowing up onto the balcony, below the balcony, so that they were getting a bit of condensation on there. So we put a bit of insulation just above it. But yeah, it's been pretty much no challenges at all. Bit of tuning to the plumbing system in terms of the return system, the loop hot water system, just to make sure that everything was in peak performance. But yeah, 3 years on, or 3 years in September, it's been what we would consider a great success. And that's it for me.
Great. Thank you so much, David. That was really fantastic. And yeah, thanks for sharing your experiences on that. Just before I introduce the next speaker, just a reminder to pop any questions that you have in the Q&A boxes, and we'll get to them after this. So without a doubt, I'd like to introduce Jackie, who is from North Sydney, and she managed a heat pump installation in her building, which is a small building of 5 units. Over to you, Jackie.
Hi, good morning, everyone. There we go. Thanks. Hi, I'm in a block of 5 units. You can see that our situation was a little bit similar in that we're just 5 units stacked on top of each other. So what you're seeing is the top 2 levels, and then we have the 3rd level where we had the heat pump and the all our hot water common for the whole building placed, and then underneath is another unit. So we have the 5 units there, and they're all 3 to 4 bedroom units. So total we have 17 bedrooms in the whole building, and of course at least 2 bathrooms in all of them. So next slide, please. Yeah, that's our original on the left there. That's our original gas boiler we had. Just a gas ream. We found that it was our 2nd time we had that installation, and we had some issues because, I don't know, the gas would burn incorrectly. We just had to have servicing the last couple of years. It was costing us money, and most importantly, we were getting stuck with no hot water suddenly. So we switched over to the one on the right, which was a heat pump. We thought we would give it a try because everyone was saying how good it was, and council had come through and audited our building and suggested that. So it slotted in directly into the same spot we had before, which was great. No issues at all. However, as it was a slightly different situation, we received lots of quotes, and most of them were telling us to get a much larger system, which was going to be quite expensive. The least expensive quote we had offered us the option of putting in this smaller 400-liter tank and having the option of adding a second one later on if we found we needed it. So that's the option we went with. As you can see, the tank is in our room in the garage, so it's pretty well insulated. And then we put the compressor outside on the other side of that wall. Next slide, please. Okay. So before we had all our gas meters also are in that space, and everyone has gas for their heating and for the cooking in addition to the hot water. The hot water has been billed from council, not from council, from the supplier. And when we remove the gas hot water, we retain the meters. And so you can see only one on the bottom has been locked, which is one one resident who has decided to go all electric. And on the right-hand side, you can see the photo of the recirculating pump. Because it's got to go up 2 levels, we opted to have that installed, and we wait maybe 20 seconds max for hot water to come through. Yeah, let's see. It does take power, but we found it was worth it, and we were worried about wasting water. Okay, next one. Now for figuring out how much each of us was spending, since it was a common pump and common system, in the past, the gas suppliers would charge each individual apartment. So we spent additional money and we installed the little sub-meter, electrical sub-meter. And so what we do is, it's all very simple, but we're only 5 units and 4 owners, and at this point, only 17 people. So we just sort of extrapolate. We take how many kilowatt hours we've used, which is read from that meter. Then we go to the legacy hot water meters, which we still have installed. Nobody's touched those. And we just calculate how much each apartment has used. And then we multiply by the highest commercial rate of electricity per kilowatt hour, and then we divide it up. And each unit pays it back to the strata. Yeah. Right, and the next one. Yeah. So there you have all the figures. So altogether, it was good for us because we spent less than $7,000 for a heat pump system, and all the quotes we had to change to another gas system was coming up closer to 8,000. So for that, that was excellent. And then now we find our bills are easily halved. Again, interesting to hear what you had to say earlier, but yeah, we work out, it's about $55, $60 a person at this point for gas of how much they're consuming. But since we have renters, we just decided we could absorb all the costs, but we decided to charge everybody exactly for their consumption. Yeah. And what's the last one? Yeah. So we've, subsequent to that, we've put in solar panels in the building, and we have plenty of power. So there you can see the figures for everything it's put for us. We'll be very happy. I think that's it. Any questions? Whatever I missed out?
Thanks so much, Jackie, for that.
Sure.
We'll just, the questions will be shortly.
Okay.
But I'm really interested in the different billing solutions that you and David came up with. So it's very interesting to me to see how you're handling that. Just quickly, we're going to run through what resources we have available across the 3 councils. So I manage a program called Building Futures, which focuses on apartment buildings, 25 apartments and above, and we provide support to reduce common area energy consumption. And that would involve potentially upgrade of a heat pump hot water system or swimming pool heating. And we are recruiting now. We're hoping to start our new round in mid-August. So we'll send through details of our program in a follow-up email. We also have some sustainability rebates just till the end of the year for hot water electrification and pool heating electrification. I'll pass over to Elsa.
Great, thank you. So from the City of Sydney, we've got a few things on offer. We run 2 programs, Smart Green Apartments and Green Building Grants. Smart Green Apartments is a yearly intake and Green Building Grants is open twice a year. As Rachel said, all the links to all of these will be sent out shortly after. We also have a monthly newsletter where case studies and all other webinars like this are advertised. And we also have a closed Facebook group as well to try and connect building managers, strata managers and committee members across Sydney. So yep, send the links and feel free to join those. Ian, I'll throw over to you to talk through what you have at North Sydney.
Thanks. Yeah, my name's Ian. I manage the Future Proofing Apartments program for North Sydney Council. The primary aims are to lower costs of living and to reduce greenhouse gas emissions in strata buildings of all sizes, so from anything from 2 and above. And the way it works is our consultants do a site assessment and provide a report with the business case and description of the opportunities. And we also provide a follow-up Zoom call to help the strata owners move forward with their plans. So that's the program, and we also jointly have sustainability rebates which apply to apartments as well as freestanding houses. And we do webinars and live events as well. Thank you.
So now we're going to move into the question and answer, and I think Elsa's going to go through all your great questions in the Q&A, but when you registered you also had quite a lot of questions come through, so I'm just going to address a couple of those while Elsa gets prepared. We did have a question on heat pumps in heritage buildings. And look, there should be no issue with installing a heat pump in a heritage building as long as the heat pump unit or the compressor is concealed or sensitively located, so not street facing or not on a principal heritage facade, but I'm sure that, yeah, just common sense would prevail there. But please check with your duty planner at each council that you're at. Another question we had was, a legal question, does changing from gas to electric common hot water require a special resolution or bylaw in New South Wales? So the advice I've been given is that it does require a bylaw as it's a change to the common property and it's voted on by way of a sustainability infrastructure motion. And in New South Wales, I understand that the resolution will pass if 51% of the voters at the meeting, present or proxy, are in favour. But David and Jackie, I guess, did you guys go through that sort of formal voting? Yes,
Not
great.
ours, but
Okay.
we're only 4
Yeah.
owners, so it was very.
Yeah. So we did. We went to AGM for the for both heat pump and solar.
Great.
So
Okay.
it was covered at the AGM that year in 2020. So
Okay, great. Thank you.
and for what it's worth, there was very little pushback. In fact, there was none. So yeah, it was pretty well received.
Great. Thank you.
I think in our case, we're a small group. It doesn't compare to yours, David, but I think if you present all the information, then it goes quickly. And that's what helped for us, it really helped by having the council study done, like the future proofing, because then it just went right through. Everyone looked at it and said, okay, let's do it.
That's very positive. Elsa, did you want to take a couple of questions from the chat?
I sure do. So I guess one that leads on from that, a question saying, for the case studies, the apartments mainly owner occupied, and just saying that maybe there's more appetite to convert for people who are actually living in the apartments rather than investors. But has anyone from either James, David, or Jackie, if you've successfully used a strategy for landlords to include utility bills in the rent and therefore get the benefit as well? So I don't know if one of you wants to jump in.
I'll jump in. So I did try and answer that in the comments, but basically part of the pitch, if you want to call it that, from me at the AGM and to the two investors is that, you know, there's a lot of benefits tied in with this against what's potentially a low cost. So, you know, there's a property value increase. It's more rentable. What was the other thing I put down there? And just, yeah, it was more around the desirability and the financial benefits, you know, taking out the fact that there's an environmental benefit to them. It's more about, you know, from an investor's point of view, they're not going to miss out. And if they really want, they can increase their rent. If they increase their rent by $5 a week, they're more than covered. Do you know what I mean? It's so, that was basically the argument that I put forward, and again got no pushback at all, because really we're not talking a lot of money here, you know, in terms of ongoing cost to the landlords or to the investors.
Yeah, that's great. Thank you, David. Another question, which may be for Conrad or David Robinson, is a building needs to install a heat pump in the roof space, which requires a crane to install, as the buildings range from 10 to 14 stories high. What are the kinds of problems or issues that they need to look out for when doing a crane installation?
Cost is a big one. So if you're getting a crane, consider that you might have to pay $20,000 to $50,000 just to rent the crane for a day. The other thing is getting council permits to actually operate the crane. You might have to shut the street down potentially. So if it's a single lane street, you need traffic control, and you need to make sure that it is safe for people to actually operate. Typically, it might be worth looking at installing something like a DAFID crane on the roof, so a portable crane or something that you can actually attach to the structure that allows you to lift the heat pumps or tanks up to the roof, depending on the capacity. There are smaller. So I guess this comes back to the actual calculations as well. So if if the gas system has been sized for, I don't know, 20,000 liters or 10,000 liters per hour peak, and then you find out that that's actually your daily usage, you might be able to get away with much smaller tanks, much smaller heat pumps. There are heat pumps that fit, in a 700, 800 mil width door. And tanks as well. So you might be able to get away with 400 liter tank or 600 liter tank and a smaller commercial size heat pump that's maybe 16 or 30 kilowatts, that potentially you can lift up the emergency or fire stair, or however in the lift. I'm not sure what sort of building this is, but there are other ways around that.
Yeah, great. David Walton, I can see you've got your hand up.
Yeah, slightly topical for me because I was helping out or just giving some advice to another strata manager or strata building manager in Maroubra, 5-story building, same thing. They were looking at putting it on the roof. One of the other considerations is also the loading, because in some cases, if it's an instantaneous gas, hot water, or a smaller, they're smaller units. So, we had 1,100 litres. Now we've got 2,500 litres of storage because of the recovery rate of heat pumps. So you need to also consider the loading on the roof. If you're doubling or tripling the amount of, 1,000 litres is a tonne. So, I guess most roofs may be fine with that, but there's also a consideration about what you're putting on the roof, because if you're putting a lot more weight on there may be implications. That's all.
Yeah, fantastic. Thank you. The next question I have is a bit of a long one, so bear with me. I think Conrad and David Robertson, this might be aimed towards you. So the New South Wales Energy Savings Scheme is subsidising the replacement of electric storage and gas domestic hot water systems in residential applications with heat pumps, which has resulted in very inexpensive heat pump installations. Do you have any advice on purchasing these systems?
I think it's always good to do a bit of reading about a particular heat pump. I know there's a lot of cheap heat pumps flooding the market, particularly now, because there's opportunity. It's a bit of a gold rush at the moment. So I think it's important to try and understand what you're installing, same as buying a car, right? You do the research, you try and understand what exactly you're going to spend your money on. That's the first thing. I think also what sort of refrigerant as well. A lot of the cheaper heat pumps might use a Type F R134 or something like that. A thing to note about those type of heat pumps is they don't really work that well when you're at 5 or 10 degree ambient temperatures. So important to consider, I guess, what's going to happen in winter. Are you going to have hot water? Are you going to, is it going to be adequate? So just a couple of things to consider. And yeah, I guess where you install it as well, just a general note, but you don't really want to install those type of units in your basement if there's no airflow. You'll starve the air basically. So yeah, just something else to consider.
Yeah, I'd add as well, consideration of maintenance is important. So going with a reputable supplier that is going to still be around in 10 years' time for parts, product support, things like that is probably going to pay dividends in the long run. So similar to any other product you buy, right? If there's a need to interact with the manufacturer and replace parts with spares or the like, having it readily available in the market and good product support is going to pay dividends.
That's a great point. Thank you, David. All right, next question, James, is for you. So with your pool heating case study, were there any changes in the electricity and gas tariff rates which could have contributed to the higher cost of electricity versus gas, or was there any other bits of plant equipment that were encapsulated in those figures that might have, played a part in those numbers?
Yeah, it's quite tough for me to pinpoint an answer to that, because I wasn't here during that transition from the gas to electricity. But I would have said so. Yeah, I would say that there would have been a change in the tariff. But that's unfortunately all I can tell you at the moment. I can do a bit of digging if that person wishes, and I'll be able to find out a few more answers.
Awesome. Thank you so much. Just looking through some more questions here. There's lots coming in. I can see some of them been answered, and unfortunately, David from Aruba has had to shoot off. But one of the questions was, what is the weight of the heat pump unit? So the same one that was used as the Maruba project. So the weight of that is, I think, is around 385 kilos, excluding the storage tanks. So thank you to whoever answered that in the chat for me. Question about indoor and outdoor for a heat pump system, and is there a limit as to how far apart storage and the heat pump can be, or is it just the costs for the additional pipe work?
So typically, you need to have a circulation pump between the storage tank and the heat pump. So if you've got a if you've got a 70-story building, it's a bit impractical, I guess, to circulate the system. But if you're going to separate this, the heat pump and the tank, just make sure that the pump is sized adequately for the pipe work that it has to circulate, as well as the flow rate required. Suppliers can help with this. So I think I've seen on projects where 2 or 3 stories difference might happen between the tanks and the heat pumps, so that the tanks can be inside, bit better insulation and protection, and then the heat pumps are located where there's adequate airflow on a roof or a well ventilated space. So it can be done. It just depends on the distance and pipe work, yes, but also the circulation pump.
Thank you. Sorry, I'm just scrolling through all these questions
Elsa,
now.
I've
Yep,
got
go
a
on,
couple
Rachel.
of questions that are
Yes, great.
So one was like, what contractors are required to install new heat pump and remove the old system? Is that one for Conrad or David?
What was that question? Sorry, Rachel.
Sorry, who installs the new heat pump and removes the old system?
Yeah, typically the plumber will do it. So plumbers can do it, mechanical contractor can do it. There is electrical work that has to be considered, so you need to have the electrical work certified. Obviously, there's refrigerant in the unit, in the heat pump, so that needs to be considered as well. I know there is actually a big shortage of skilled plumbers that work on refrigeration. I think the Master Plumbers Association said 30,000 people shortage. So there is quite a shortage. So I guess there's a lot of upskilling to happen. So potentially one thing that might happen is, finding a plumber that will actually work on the heat pump. So that's something that you have to consider. It's a good question to ask them.
Great. And then just a follow up to that, who should people go to for sizing questions around heat pumps? I might give that to David Robinson for either pool or hot water.
Yep, sure. So you can go directly to suppliers, and that's probably going to be most appropriate for smaller to medium applications. If it's quite a large installation, perhaps at that point you'd be able to go to a smaller engineering consultancy. So they'd be able to provide specific design advice. And there's, I guess one thing to be aware of with a supplier, and it relates to one of the other questions that's been asked in the chat about the cost of the system. There can be a little bit of a conflict of interest in some situations. the supplier may be looking to upsell you on a larger unit and make more money as a result. But if you were to go to a smaller engineering consultancy, that conflict of interest is removed. So they can give you more independent advice. Another way is to shop around a little bit. If you talk to different suppliers, you can see the types of system that they're proposing. You can dig into some of their numbers and sort of cross-reference the assumptions that they're making.
Just to add to David's point, so something that building managers can do, if you've got a water meter serving the hot water plant, you can take physical readings. So we've done that on projects where we've asked the building managers for existing projects going into electrification to actually take, a reading at 8 a.m., a reading at 12 p.m., and then a reading at 4 p.m., and then do that over a week or two to get some actual demand calculations. So that, I guess, it's sort of coming back to the point. We had one building where the gas plant was being sized for 13,000 litres peak hour, and the actual building demand over 24 hours was 21,000 litres. So way oversized. So it sort of meant that you could actually, as a building manager or strata, actually have confidence in going to a supplier and saying, can you size it for this with some redundancy in the system, and don't give me 50,000 liters system. A smaller system would be able to handle it. But also, I guess, coming back to heat loss, heat loss needs to be understood as well. So that's something that hopefully a supplier or a consultant can arrange. A simple way to measure it would be to have a plumber come with a clamp-on flow meter and actually measure what the flow rate coming back would be, and then the temperature, and then you can do a very simple calculation to actually calculate what your heat loss is. So there's another suggestion. We did that for another project, and I think it was about $3,500 to have data for a week from a plumber, and then an Excel spreadsheet provided. So there's another option.
Fantastic. Thank you. Look, there's still lots of questions, but we're just coming up to closing time. I believe, Elsa, have you got a poll that you're about to launch?
I sure do. So yeah, we're just about to launch a poll. Just let us know what you thought of this webinar. It's really great feedback for us. Yeah, love to know your thoughts. And look, we've taken a note of all the questions. We will try and answer as many as we can and send it along the follow-up email with the recording as well. So that poll should be launching now, and I'll hand back over to Rachel.
We just wanted to say a big thank you for attending today and giving up your lunch break, but a huge thank you to all our speakers who've given up their time, some of them unpaid, to come along today, and special shout out to Jackie, who has come in from France and got up in the middle of the night. So really appreciate your passion, Jackie, and getting that message out, and all your expertise. So thank you, David, Conrad, James, thank you, David and Jackie. So as Elsa said, we'll send up a follow-up link, but please, contact details will be in there of the relevant council officers. Please don't hesitate to reach out to either join an existing program or if you need any more support on embarking on an electrification project. Thank you for coming today. We really appreciate it.
Thank you. Thanks, everyone.
Thanks,
Thank you,
everyone.
everyone.
Thanks, all.
Thank you.